Hello. Hello. Am I audible?
Yeah, audible, sir.
Yeah, yeah. Just give me 5 minutes. I will start. 2 or 3 minutes. I will start. स्क्रीन रिकॉर्डिंग करना है। हाँ, स्क्रीन शेयर करना पड़ेगा तभी तो होगा। ठीक है, नहीं आता। Hello. All of you have attended the classes of Professor Sounak Choudhury. I think first week classes. All of you have done the first week lecture, na? Anyone of you? Could you please say? Okay. My screen is visible to you all. Is it okay? Hello. Okay, my screen is visible to you all.
Yes, sir.
Yes. Okay.
Yes, visible.
Okay, just wait. Someone is trying to join. Okay. Please join the classes on time, actually. Otherwise, okay. Okay. I think all of you have studied the first week classes, all the lectures from Professor Sounak Kumar Choudhury, IIT Kanpur, Mechanical Engineering Department. All the five lecture series you have attended. Now, today is the live tutorial classes on the basis of the first week of all the lectures. Is it clear? Hello?
Yes, clear.
Okay, okay, okay. Myself, Subrata Kumar Maiti. I'm a PhD research scholar in the Department of Polymer and Process Engineering Department, IIT Roorkee. And this subject, the manufacturing processes and casting and joining, this is specially designed for the student of the department from the various departments like mechanical engineering, productions engineering, design engineering, and manufacturing science. Okay. This is the first week lecture, live lecture series on on manufacturing processes, that is casting and joining. Okay. I think all of you have the basic background of the casting processes. Okay. In the first week, whatever you have gone through, this is basically a brief introductions on the casting, and I will go through with the some details of the basic principle of casting and the basic details of the casting. Then I will solve some numerical. Okay, someone is joining. Okay, then I will solve some numerical. Okay, this will be very helpful for your basic understanding, and if you were attending the gate exam and like this competitive exam, it will be helpful for you also. Okay. uh, First of all, I will go through some basic. Yes, just 1 minute. Please try to join in time, actually. Otherwise, okay, I think I should start. Uh, this is a subject of manufacturing process. Okay. What is the subject named the manufacturing process? This is a very simple that anything, any object we are going to manufacture, like any automobile part, any home appliance, this is manufactured by a certain process or by a certain principle. Okay. Anything. Suppose you were drinking water, this drinking water by a glass, metallic glass, how this glass is prepared by. Okay. On which processes this glass is prepared. Suppose an automobile, there is a different part consisting in an automobile, the different part, how it is manufactured. Okay. The different process. You cannot say this different part will be manufactured only through a particular manufacturing processes. This is a different manufacturing processes. Different part will be prepared. Okay. For manufacturing, the first thing, the first sections actually comes the major, the important part is coming, that is the metal casting or casting. Okay. We'll study the metal casting here. Okay. Uh, Metal casting means, what is the casting means? Casting means anything you were going to cast. Suppose one building is, during the time of the building making, the floor is casted by steel rod, sand, concrete, and different thing and cement. Okay, this is also casting. Here we are going for the metal casting. Okay, in that case, during the building or floor casting, the material was used sand, cement, butter, steel rod. This is the thing. But in the metal casting, we will use only the metal to give it a particular shape or size. Okay, this is the metal casting. Uh, what is the importance of metal casting? Okay, there are the, we can divide it into three part. The manufacturing process can be divided into three parts. First, first, first is the, any object we are going to manufacture. Any object we are going to manufacture. Suppose material removal process. Okay, material removal process. This is the basic things you should understand. Material removal process. Material removal process. Okay, and second is the constant mass operation or casting. Casting. Third is the mass addition process. This is important. Mass addition process. Mass addition process. On the basis of three main principle, anything you can manufacture. Okay, any material, any automobile parts, any home appliance, or anything you are going to manufacture, just you have to apply this, any one of this process or maybe the combinations of the processes. Okay. First one is the, just let me check. Some students is waiting, I think. Okay. Uh, my voice is clear to you all, na? Hello. I think my voice is clear. Hello. Okay, 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 okay. Okay. First one is the what I have written here, the material removal processes. Okay. Material removal processes generally suppose you have one billet in cube form. Okay. Okay. Suppose I am asking you to make it a rod cylindrical shape. Okay. This is cube shape or rectangular shape. This is rectangular shape. Suppose I am going to tell you, I am asking you to make it a cylindrical shape. Cylindrical shape. What is the process you are going to use? Anyone of you can say. Just you unmute and just you say. Hello. Do you know or not? If you don't know, you can clarify here. Anyone of you can say yes or no. I will say yes, yes. Please continue. Vijay Manikanandan. Vijay, do you know? Ashish Yadav. Ashish, are you there?
Turning operation on lathe machine.
Ajinkya. Yes, yes. Lathe operations. You were very right. Try to give the answer, whether it's may wrong or right doesn't matter. You just tell something. I am also student like you. Say something. Okay, I think I don't know. Uh, if you have one rectangular shape kind of billet, if I am asking you that just make it cylindrical shape, obviously you will apply the lathe operations, like it is called machining. Okay, just it is called you have to machine it. Okay. You have to put one tool. Okay, carbide tool or something, a tool you have to use. Okay, and this object will be rotated. Okay, and you just it will the fine chips will come out and it will make the shape will coming in a cylindrical shape. Okay, and the tool is moving in this directions to make the whole surface in a cylindrical shape. Okay, this is the machining operations. Here is the material is removing. Okay, the material is material losses. Okay, material losses occur. So this process is called material removal processes. Okay, this is also manufacturing process. You can make the cylindrical shaping rod. You are just preparing cylindrical shape rod from a rectangular shape. Okay, this is also a part of manufacturing process. Second is the casting. Suppose I am asking you just okay, first day I think the students are coming late. Okay, okay, no issue. Okay, this is the first type of material removal process. Why the students coming so late? Okay, okay. Suppose I am asking you make the cylindrical rod in another process. You can apply another process for making the cylindrical rod. You have to prepare this cylindrical rod. You have to prepare this cylindrical rod by another process. In which process you can make this cylindrical rod other than the machining processes? Any one of you can say?
Through casting,
Very good.
roll
Huh.
casting.
Yeah, through the casting process. You know the casting process is like that. I will prepare. Should I accept the students? They are coming late or no? The first date is okay. I'm accepting. Please, dear students, try to attend the classes on time. Actually, otherwise during the class time it is getting late. Okay, this cylindrical type shape can be prepared also by the casting process. Okay, where you have to make the mold cavity. Mold is made by the sand. Okay, mold cavity, you will make a cavity of the cylindrical shape, and easily you can pour the liquid molten metal into the pore cavity, mold cavity, and the cylindrical shape will be prepared. Okay, this is called the casting process. You can easily see that the cylindrical shape rod can be prepared from both the processes, material removal processes as well as the casting processes. And next one is the mass addition process. Okay, next one is the mass addition process. The same example I am giving you. Okay, the same example. Suppose you have the rectangular kind of material or steel rod, rectangular rod, or cubic rod. Okay, this cross section is the rectangular type. Okay, or cube type. If I ask you to make this rod in a cylindrical rod by the mass addition process, by the mass addition process, is it possible to make through the mass addition process? Any one of you? Hello, is it possible or not? Just just say something. Hello. Yes, yes. Just say something. It may be wrong or right. Anything you can express yourself here. You are also students. I am also students. Kausik, Kausik Pal. Just say something. Vishnu. Okay. This is also possible actually. Okay. How this is possible? But this is not the very worthy actually. Okay. How it is possible? You can add some material uh, through the corner side, and you can try it to make, or try you can try to give it shape, a rectangular kind of shape, by adding some material over the surface. But it is not so much good process, or it is not so convenient process actually. Okay, but you can make it. Okay, so there are three, on the basis of the three major principle, the overall manufacturing process is stand on. Okay, first one is the material removal processes, second one is the casting, and third one is the mass addition processes. Here we will study the casting processes only. Okay, you know the definitions of the casting already you have studied. Okay, a metal casting is a shape obtained by pouring liquid molten metal into a mold or cavity. Okay, and allowing it to freeze, thus take the form of the mold. Okay, I think you have studied it. Okay, it is very simple. Okay, this is also the basic thing, how the component, any component of automobile or anything, how the final product can be prepared. Okay, the final product you will get. Okay, first you have to take the raw material. Okay, first of all you have to take the raw material, then you have to go through the different processes. Okay, uh, you have to choose one component. Okay, uh, you can prepare by casting directly. Okay, or you can go through the preliminary forming. Forming is like that, the different machining. Okay, lathe operations, cutting, grinding, different thing. Okay, and this is the secondary operation. Okay, this is also including the machining, grinding, all the things. Okay, and finally you have to give some finish. Okay, surface finish, like, okay, on, or maybe some joining processes is there. Suppose you are going to make one t sections. Okay, t sections, so you have to make the two different part. Okay, then you will join together to make the final product. This is the t shape. Okay, this is the joining process or assembly process or finishing process. After preparing the thing material, you have to give the surface finish. Okay, such that the material can be usable or user friendly. Okay, or you can easily use. Okay, this is how the final product you can get. Okay, but here we will only concentrate on the casting processes. Okay, okay, okay. These things, this is the very basic things you have studied. The type of mold you can use, that the sand mold. Okay, or permanent mold you can use. Okay, these things, basic things, I will not describe here. Okay, okay. uh, Classifications of the casting processes: expandable casting is expandable mold and permanent mold. Okay, expandable mold means that it is single time usable mold. Okay, like sand casting. Okay, you are giving a shape. Suppose you have to prepare one cylindrical rod. Okay, these kinds of outside the cylindrical rod. Okay, there will be sand and inside, and you have to prepare a mold cavity like a cylindrical cavity. When you pour the material, molten metal, and this molten metal will take its the cylindrical shape, and finally you will get the rod type cylindrical shape type material. Okay, so this is the sand. Here sand is used for the casting. Okay, so this sand, after getting the final material, you can break this sand. Okay, and you will prepare next type of anything you in anything you material, any material you can prepare. Okay, and the sail molding. Okay, the sail molding is it's a like a sail. Okay, and the outside sail will be removed. You will get the product, desired product. Okay, and investment casting is also very expensive. Investment casting is a very expensive casting. You will study later. Just you show here the classifications. Permanent molding, it is the die casting, centrifugal casting, and continuous casting. Okay, this is the permanent mold. Here the sand is not used. Okay, this is the some data you can go through. I am not going through details. Okay, what is the main advantages of the casting? What is the basic? What is the advantages of the casting? The main advantages of the casting is there is no loss of material. Okay, there is no loss of material. Suppose you are making one product by casting, you will pour the liquid molten metal into the mold cavity, pour the liquid molten metal. Okay, and you will give one particular shape. Any extra material, extra part, you will just machine it off, and then again you can melt it for the reuse, and you can again prepare another casting. Okay, there is no loss of material. Okay, that's why it is called constant mass operation process. That's why it is called constant constant mass operation process. Constant mass operation process. But for the case of the machining, the material will be lost in the form of chip. Okay, this is the main advantages. And another advantages is that the very large part you can manufacture. Very large part you can prepare very large part by casting processes. Okay, this is the important part. What is the disadvantages of these casting processes? The mechanical properties like porosity, strength may be damaged, or mechanical property may be decreased due to the porosity. Actually, how the porosity will come? Do you know? Any one of you? How the porosity? How the porosity will come into the final product? Hello.
No, sir.
How the porosity will occur during the casting processes? You don't know. This is a very simple thing. You should answer. Due to shrinkage. No, no, no. Due to shrinkage, no. Yes, trapped gas. Exactly. Sri Sri. Sri Sri has answered, but he is messaging. You can unmute and you can say, okay, yes, due to the trapped gas. How the gas will form? Any one of you can say? How the in the mold cavity, suppose this is the sand, I am preparing one cylindrical rod. How the gas will come? How the gas will come? How the gas will come? I have to actually vent this gas out. Okay. Otherwise, the porosity will come. I have to vent this gas. How the gas will generate inside the mold? Because when you, say something.
Due to water in mold,
Uh, Due to water in mold,
mold sand.
it's okay, but not exactly due to the water.
Then maybe the pressure differences due to the
No, no,
temperature.
due to no. Actually, what happened during the preparations of the sand mold casting? You have to take sand. There is the sand. Is it only the material sand is used or something other material you were going to use? Sand, sorry, SAND, water, and
Silica.
silica is the sand. Another
Clay
additives.
Clay.
and additive.
Yes, water and clay and additives. Additives like wood chips or coal. Okay, wood chips, wood chips. Just to make it giving the proper strength or binding to the sand, because sand is a very loose type material. Okay, you cannot hold sand cannot hold itself alone. Okay, if you add some water, if you add some clay and some additives, then only the sand will have its permanent strength. It will make a it will have a proper strength. Okay, such that you can make a cavity. Otherwise, sand itself collapse. You cannot make the cavity inside the sand. Okay, suppose this is a sand field. This is a sand field. You have to make one insider hole, I mean cavity. You have to make one cavity inside the sand. If the sand only is there, you cannot make the cavity. You have to add water, clay, additives. Okay, and additives, why the additives is used like wood chips. Okay, when you will pour the hot molten metal molten metal, what will happen? This this wood chips will burn out. Okay, and it will produce carbon dioxide, different gases. Okay, these gases will these gases should be burned out. Otherwise these gases will interrupt to the casting material, what the product you are going to prepare, okay, these gases should be vent outside or in the environment. Okay, if the gas does not come outside, the gas interrupt into the your product material, and the product will be porous, porosity will be there, okay, and the quality of the product will be less. If the some air bubble trapped into the material, your material quality will be decreased and the mechanical strength will be decreased. That's why you have to vent out these gases, okay. But why we will add the chips, okay, this wood chips is bad because it is producing some gas. Why we will add some additives like wood chips? Because if only the sand and clay is there, okay, when the molten material, you will pour the molten material, its volume will be its volume is a little higher than the when it will shrink. After shrinking, the volume will be less, okay. After shrinking, after shrink, volume will be less. After solidifications, after solidifications, volume will be less, okay. Then during the molten metal, the volume is higher than the after shrinking type. The adjustment, this adjustment of the volume higher to lower, this wood chips is added, okay. And the when the wood chips will be burned out, the sand, the distance between the two sand will be higher, such that the gas will be easily vent out, okay. There are the two advantages of this adding the wood chips, okay. You can say three advantages. It is a binder for the giving the strength. After burning out, the sand will be more porous, the gas will be coming out easily, okay, and the adjustment of the volume will be easier, okay. That's why such types of additives will be used, okay. I'm not going into details of the historical background. This is the big pillar made by casting processes only, okay. The main advantages of the casting process is that you can make a very heavy or larger size product, okay. This is the example of making the larger size product, okay. The different automobile parts can be manufactured by the casting processes, as well as the we can use the metal removing processes, or you can use the mass addition processes. Can you give the one example of the mass addition processes? Mass addition process, third processes, third manufacturing processes, whatever I have discussed, third manufacturing processes, mass additions. What is the mass addition example of the mass addition manufacturing processes? Mass addition manufacturing processes example.
Casting.
No, casting is a constant mass operation process. That mean final product mass of the final product and the initial product mass is the same in the casting process. But I am telling you something you are going to manufacture. The initial mass, final mass will be higher. The final mass will be higher than the initial mass.
Welding, sir.
Yes, welding. Because
Welding. Welding.
yes, welding process, welding or rapid prototyping or 3D printing. Okay, what is the 3D printing? 3D printing. Suppose, okay, suppose you are going to make one model of plastic model, building model. Okay, suppose just I am making one building model here. Okay, this is small building. Okay, small home. Okay, 3D printing. You are going to 3D print it. Okay, and suppose you are adding, you are designing that one extra room. You need one extra room. Okay, for the designing purpose. Okay, if you add, if you go for the 3D printing, 3D printing, 3D printing, you can easily make the 3D printing by adding one extra room in your model. Okay, this is the mass addition process. Here I am adding extra mass. The final mass is the higher. Suppose you are welding, you are going to two pieces, you are going to weld. Okay, in between they have to fuse it together, and you have to add extra filler material. The obviously the final product will be mass will be higher. Okay, so mass addition process is basically the welding processes and rapid prototyping processes. Okay, and continuous and constant mass operation process is the casting process, and material removal process is the lathe machining processes, different machining processes and surface finishing processes. On the basis of the three basic principle, the manufacturing processes is there. Okay, you should understand. I think this all the video you have studied. Okay, I will not go. Okay, pattern. What is the pattern? What is pattern? What is pattern? Is it required in the casting process?
Yes, sir.
Yes, sir.
Yes, yes. How it is required? That first of all, if you going to manufacture any piece of material, okay, you have to make one replica of this, of your product, of your final product. Replica means that the same things you have to prepare. Okay, by using the different material like wood or not costly material. Okay, easily available material. Okay, then you have to make the mold cavity inside the, by using the sand. Okay, green sand molding. Okay, then you will pour the, and then you will get the desired shape inside the mold cavity. Okay, then you will pour the liquid molten metal. Okay, then you will get the final product after solidification. So pattern is the preliminary part you have to prepare. Then by using this pattern, you will make the mold cavity, I mean inside the sand. Then you will pattern will be removed, and it will mark a hollow space, and this hollow space is filled by molten material, and after solidification you will get the final desired product. That's why pattern is the preliminary part. Okay, but during the preparations or during the making of the pattern, you have to add different allowances. Okay, suppose shrinkage allowance or draft allowance, machining allowance. Okay, do you know that what is the machining allowance? Why we required machining allowance after casting?
Material
Well,
balance.
to
Huh.
get the proper surface finish, the machining is
Yeah,
we have to remove the extra amount of material, and
yeah.
that's why we require the machining alone.
Okay, good. And what is the draft allowance?
Draft is to remove the pattern casting product from the
No,
molds.
to
So
remove the pattern
to remove the pattern from the
mold.
molds,
Huh.
means it should not be collapsed.
Huh.
So
Yes,
that's
yes,
why we are providing. That's why we
yes,
are
yes.
providing the draft
Yes,
allowance.
very good. Suppose I have one sand. I this is the sand. Okay, you have one kind of pattern. Sorry, one kind of pattern here, wooden pattern. Okay, suppose I have to remove this pattern, then only there will be mold cavity. There will be cavity. Suppose I have to remove it very smoothly. Okay, and another pattern. I am making another pattern here. Suppose here is the another pattern. This is the another pattern. Okay, which one will be easily removed and without any damage of the mold cavity? This is the first one. This is the first one. This is the first one, and this is the second one. Two is the second one. Without damaging the surface of the mold cavity, which pattern will be suitable? First and second. Which option is the right?
Second.
Why?
Taper is there.
Yes, yes, yes.
Draft
There
is
is a
provided.
draft is provided. Taper means some angle is there. Okay, such that it will the mold cavity will be less damaged. Okay, and after that, as I have added extra material, like here, just I am trapezoidal shape. And as I have added extra material, this extra material will be removed. This extra material will be removed by machining processes. Na? This extra material will be removed the machining processes. This extra material is called the draft allowance. Is it clear? Is it clear?
Yes, sir.
Okay, okay. This is the single piece pattern, split pattern, match plate. You will study it yourself because it is very theoretical part. I will solve numerical actually. What is the time? One numerical. I will solve one numerical. Okay. This one numerical will help you understanding all the things. Okay. And if you solve this numerical in your gate examinations or any other examinations, your basic concept will be very clear. Yeah. Just admit. The students is yet coming. It's 7. Okay. Please try to join on time. This is the theoretical part. I am not going to in details. What is the cope and drag? This
Upper and lower,
top is the
upper and lower part of these mold.
what is the top part is called cope or drag.
Upper part.
Upper part is ha. This is the just you remember these questions because in many examinations like SSC or something examinations, JE, you can find this type of questions. Okay, this is the shrinkage allowance. Uh, why the shrinkage allowance is given? Because uh, you have to make a slight larger size cavity or larger size pattern because when the liquid molten metal fill the larger size cavity, suppose this is the larger size cavity, okay, liquid molten metal filled, after solidifications, you will observe that the volume is like this, okay, because due to the shrinkage. Okay, after solidifications the volume will be less. Okay, that's why you have to prepare slightly larger size. Okay, that's why you have to make the pattern in a larger size. Okay, this is actually because of the expansions coefficient of the expansion of the material. Okay, due to this shrinkage allowance you can calculate. This upper part is the cope. This is the very important. Upper part is the cope. This is the parting line. This is the parting line. The mid line is the parting line. Okay. Upper part is the cope. Full upper part is the cope. Okay. And देखो, this is the vent. Okay. The vent is provided. Why the vent is provided? Because at very high temperature some gases will be produced and the gas should be removed out. Okay, that's why vent is provided. Okay, what is the why this is the riser, what is the working principle, what is the why the riser is there?
To observe the mold cavity, whether it is filled with molten metal or not.
Mhm. Actually riser is provided just to compensate the material inside the core,
Mold cavity.
inside the mold cavity. Okay, it hold the extra molten material, and if necessary it will come inside the core material and fill during the solidification time, during the shrinkage time. That's why riser is important. Pouring basin, you know that it is in the pouring basin the liquid molten material is poured here, and there is important thing is a gate. Okay, there is a gate, you have to design the gate. Okay, the main questions, numerical questions come uh, on the designing of the gate design. Okay, this is called sprue. This is called sprue, through which the molten material flow from the pouring basin to gate. Okay, this type of questions will also come. What is sprue? Sprue is basically carry the molten material from pouring basin to gate. Okay, this is a parting line, this is sand. You just remember this diagram. Ha, core, what is the, why the core is provided, what is the function of core? Anyone of you can say what is the function of core? Why core is
The,
provided here?
the core is provided uh, to, which is the internal part of the mold cavity.
Huh.
To
Sometime
provide
we
all
have,
of space.
yes. For a complex design or some internal complexity, you have to give some core material. Okay. Suppose here, why the core material is provided? Here, why the core is provided here? It is also a internal design, because you can see the final product here. This is the hollow portions, that's why core is provided. Okay, that means one extra material I, if I kept here, and your liquid molten material you will go this side and this side mold cavity fill, and okay, and it will make this will make the hollow, there will be no molten metal here. That's why core is provided. It is just for the internal designing of the mold. Okay, this is the things you can study. Okay. How the liquid molten material flow? It is important. The liquid molten material is pouring here in the pouring basin or pouring cup, and it will go through the sprue. Okay, and this is the getting system. This is the getting system. Getting system. I mean here, this is the getting systems. Whether this getting systems is top getting or bottom getting. Here, what is the here? It is top getting or bottom getting. Anyone of you can say whether this casting is top getting or bottom getting.
This is bottom getting.
No, you have already studied the lecture. You should say this is the combinations of the top gate and bottom getting. Okay, because this is the gate, this is the gate, and this is the upper portion. When this upper portion will be filled out, this is called the bottom gate, and at the first this bottom portion will be filled out. This is called the top gate. So it is the combinations of the top gate and bottom gate. Okay, we will study. Okay, greens and mold. How the greens and mold combinations, preparations, compositions. Sand. This is the sand. This is important question. Sand. Sand is the 70 to 85% question. Say 70 to 85% sand is used, and clay. Clay is 10 to 20%, and water. Water is 3 to 6%. 3% is very optimum. Okay, and additives like wood flour, dextrine, and sea coal. Okay, this is the combinations. And one question came in the gate. I forgot the year actually. What is the in Greenson molding? What is the water percentage? What is the water percentage? You have to remember that 3 to 6% water percentage, water content in the Greenson molding. 3 to 6%. Okay, or clay is important. 10 to 20% clay in the greens and molding. Okay, otherwise the it will not properly, sand is not properly binding. Okay, just 1 minute. Hello, अभी मेरा क्लास अभी मैं हाँ hello, is it clear? हाँ, uh, what the property you have to consider during the preparations of the molding of sand or sand molding? You have to consider the strength, like compressive strength, permeability. Permeability is important because if the smaller kind of sand, or if the any sand particle like comes together, there will be no gap. The the vent out gas cannot go outside. So you have to choose such type of sand particle that the vent gas can easily go out. Okay, this is the permeability of the sand or mold. It is important a considerations. Deformation, flowability, refractoriness, because at higher temperature the mold should not be damaged. Okay, effect of water. If I increase the water percentage in the greens and molding, like 3 to 6%, suppose 1 to 3 to 6, If we increase the water percentage in the green sand molding, what will happen? Anyone of you can explain?
Sir, if you increase the water percentage in the green sand molding, the mold will be weak because of the extra moisture.
Exactly, mold will be weak. Anything, any problem? It will be there. Any problem? Any other problem? You just see the diagram XY tensile strength versus weight percentage moisture. Then only you can answer. If we the increase the after 3 percentage, the mechanical strength is reducing. It is very clear. And what is the other thing? The
Permeability decrease.
permeability decreases. How the
Yes.
permeability is decreases?
The extra water will occupy that uh,
Yes.
porosity.
Ex,
Yes.
ha, extra extra amount of the water will be filled in the in between the two sand. Okay. So then the permeability will be less. Okay. And if the increase, and what is the case of the density will increase. It is the same thing. The density extra, the porous portions will filled by the water and the density will be increased. Okay. And below the 3 percentage, it will happen that from the 0 to 1, 0 to from 1 to 3, the density will be decreased and the strength will be increased gradually, and the permeability will be also increased. Okay, these things you have to remember. Okay, how the percentage of the water in the grains and molding will affect the mechanical strength, permeability and density. Okay, gate design is important. This is the bottom gating. Okay, there are two gating system. This is the bottom gating and top gating. This is the bottom gating. Just I am explaining here. This is the molten material here. This is the molten material, and the molten material is coming through the sprue to the mold cavity. This is the mold cavity. As why it is in the open to atmosphere? How? As it is inside the mold cavity, why this is written that the open to atmosphere? Anyone of you can say why it is written here the open atmosphere?
Others, other side is open.
No, this is totally enclosed things. You can see this is a very enclosed systems. This is the enclosed systems. But how this is the in atmospheric pressure, the course mold cavity, how I am writing the open atmospheric pressure? It is in atmospheric pressure. This is very simple. Just you see the figure and you can say, because the vent is provided and the porosity is provided into the inside the sand. So atmospheric, there will be atmospheric pressure. Is it clear? The vent is provided and the inside in between the two sand particle there will be a gap. The the pressure, it will feel like atmospheric conditions. Okay. Okay. uh, I am going to explain the top getting system and bottom getting system. Okay. This is important. I am taking some new slide. Okay. This gate design is important. Okay. uh, Suppose this is your pouring basin, and pouring basin is extended to by the sprue. This is sprue, and the molten material is feed here, and the top surface, it is called 1, and here the sprue section is the 2, and the opening at the gating system, this is the 3, and this is the mold cavity. Here this is the mold cavity, this is the mold cavity, this is the mold cavity. Is it top getting or bottom getting? This is top getting. Okay. This is the top getting system because the molten material is feeded on the top side of the mold, top side on the mold cavity. Is it clear? Is it clear?
Yes, sir.
Okay. What is the important thing? Uh, what is the time to fill the mold cavity? These questions is important. You have to calculate. Okay. Why we'll calculate the time for filling this cavity? Anyone of you can say why the time we are calculating? I think you have studied the lecture of Professor Sounak Kumar Choudhury, and any lecture you have studied BTech engineer, mechanical engineering. We are going to calculate the time of the filling. This is very crucial, very important thing during the gate design. I mean, what is the why we are going to calculate the time or interested in time? Anyone of you can say?
So due to process of solidification, sir?
Yes, because time is very important, because the if it will solidify before, suppose we are pouring the molten material and it will immediately solidifying, and it is not reaching to the mold cavity. Before reaching the mold cavity, it is getting solidified, or sometimes the your molten material is not filling the whole mold cavity. That's why time is very important. we have to calculate the time to fill up the whole mold cavity. Okay, and the solidification temperature is important. Suppose you are giving the molten metal temperature 800 degrees centigrade of steel. Okay, steel is 800 degrees centigrade molten steel. At 700 degrees centigrade, it will melt like structure. Suppose you are pouring 800 degrees centigrade steel. It is during the pouring time, the its temperature will be loose and it will very quickly it will reach 700 degrees centigrade and it will start its solidifications. The temperature is should be optimum like 1200 degrees centigrade, like that you have to maintain the temperature of the melted metal, and the gate design is important as the time considerations. Okay, if I apply the Bernoulli's equations at the point 1 and 3, 1 and 3 portion, what is the Bernoulli's equations point 1 and 3? This will be that P1 pressure 1 density rho g plus V1 square divided by 2g plus, okay, I have to give the head. Okay, uh, this is the head. Uh, this is the total head. HT is the total head. Okay, and H2 is, this is the head H2. H2 is the this head, and this head is the HC. Okay, I am applying the Bernoulli's equations at the point 1 and 3. Okay, at the 1 point, the total head will be that the HT equals to, for the 3, pressure at the 3 divided by rho g plus V3 square. You have studied these equations now. Plus it will be 0. Why I am writing 0 here? Because I have taken the baseline datum line from here. H3 is the 0 head. That's why it is 0. Is it clear?
Yes, sir.
Okay. This P1 by rho g and P3 by rho g is the same. This is the atmospheric pressure, atmospheric condition. Why this is atmospheric conditions? One is the atmospheric conditions, during the pouring molten metal, it is in atmospheric conditions. It is very okay. But inside the mold cavity or at the gate system, at the gate portion, 3 portion, this is the gate. This is also atmospheric conditions. Why I have clarify you. Okay. So P1 and P3 is the same atmospheric conditions. So we can cancel it out. Okay. So, and the V1 velocity, what is the V1 velocity? Just I have started the molten material here, pouring. The velocity of the molten material at the one section is, what is the value of the V1? What is the value of the V1? Velocity of the molten material at section 1? Could you say? V1 is the
Is it zero, sir?
0, because we are just started pouring of the molten material. So molten material velocity is the zero. After that, the due to the gravity, the molten material start taking velocity. Okay. Okay. So if we cancel out all the things, the your formula will be coming out V3 will be V3 is 2 into G under root 2G HT. Okay. So velocity of the molten material at the section 3 is the under root 2G HT. HT is the total height from the gate to where I am pouring the molten material. Okay. So our main objective is to find out the time. Okay. This is the equations 1. So how I will find out the time? Time is the total time to fill the all mole cavity, total time to fill the mole cavity, time, this is the time actually, this is the time is total volume of the mold, total volume of the mold cavity, total volume of the mold cavity, volume of the mold cavity divided by volume flow rate of the liquid. Okay, volume flow rate, volume flow rate, this is the volume flow rate. So total V is the volume of the mold cavity, V divided by AG, AG multiply V3. V3 is the volume, V3 is the velocity. Here V3 is the capital V is the volume of mold cavity, mold cavity. AG is the gate area, gate area, gate area. If it is cylindrical, then the area will be pi by 4 d square. Okay, gate area at the 3, at the 3. Okay, and V3, you know that the velocity of the molten material, we already know the velocity of the molten material, V3 is the equation 1 under root 2G HT. Is it clear? Material flow at section 3 section. Okay, so we can easily calculate the time if you know the volume of the mold cavity, capital V, and if you know the gate area pi by 4 d square. Okay, and the velocity calculated from the Bernoulli's equations by using the sections 1 and 3, you can easily calculate the total time to fill the mold cavity. Is it okay? For the case of the top gating system, is it okay? Do you understand?
Yes, sir.
Okay, next is the bottom gating. Bottom gating is a bit, you have to understand. Okay, I am trying to, I have time. Okay, uh, okay, how the bottom gating is there, this is bottom gating. Just I am looking okay, it is not actually proper diagram. This is the bottom getting. I will make you understand. Okay. The top surface is called one positions. This is one, and this is the two positions. This is two positions, and the gate system. This is the three positions, and your molten, suppose at any instant your molten material is filling up to this. Suppose this upper portion is 4. This is 4, section 4. The total height from 1 to 3 is the HT. Is it okay? And H2, this is the height from 3 to 2. This is the datum line. This is the datum line 3. This is the H2. Okay. And at any instant, at any instant, the height is the, this is the mold cavity filling molten material. This is the H, and the total cavity height is the HM. Mold height, total mold height is the HM. At any instant, this is the H. Okay, H is the variable and M is the constant. Okay, for that case, you have to apply the Bernoulli's equations at the point 1 and 3. What will happen for the point 1 and 3? This is the P1 divided by rho g plus the velocity will be 0. Here you know that velocity will be 0 plus the height is the ht. When you will not understand, you just ping me or you just say something. Okay, the at the three portions p3 divided by rho g plus v3 square divided by 2g plus 0. Okay, this is the one thing. Okay, now you can calculate what is the value of p3. Okay, next you just use the Bernoulli's equations at the point 3 4, 3 and 4. What is the Bernoulli's equations? You just apply 3 and 4, the Bernoulli's equations. This is the p3, p3 divided by rho into g plus this is the height, velocity v, v3 square divided by 2g plus height is the 0 equals to 4 positions p4, p4 by rho into g plus v4, v4 square by 2g plus h. Okay, here this is very interesting thing or important thing actually. Here v3 value is 0. Here v3 value is 0. Why the v3 value is 0? Do we have any idea v3 value is 0? Why we have considered that the v3 value is 0?
When we consider 3 and 4,
Huh?
it is like initial state.
So the time
No,
is
no. Actually, what happened? Uh, Suppose let's consider uh, at the four positions. Let's consider the four positions. The velocity of the four V4 is also zero. It is a very narrow gap, and it is a very bigger cross sectional area. Okay, this is a very bigger cross sectional area. So uh, the liquid molten material is flowing very slowly, and not the liquid molten material flow coming out through the gate, and it is the height is, as the cross section area is so high, the material is rising very slowly means not in second or hour or minute, it is in second actually. Okay, the height is comparatively, the height is very slowly, because the surface area is very high. That's why the V4 is taking 0, and the V3 is also taking 0, because uh, just at the opening position, the is kinetic energy loss completely losses. The at three at three section at three sections, kinetic energy loss completely. Kinetic energy loss completely. Okay. And that's why V3 and V4 is taking the values as 0. V3 and V4 value is 0. Okay. So this is also 0, and this is also 0, and P4, and P4 is the atmospheric pressure. As the P4 is the atmospheric pressure, atmospheric conditions, we are taking it 0. Okay. So P3 will be like this. P3 will be rho into G into H. What is rho? Rho is the rho is the density of the molten metal.
density.
Ah, density of molten metal density. Okay, molten metal density, METL. Okay, so you have one equations, this one, and you have these equations, two equations. If you put this two into one equations, you will get, you will calculate in your home, otherwise you cannot understand. Okay, if you put equations 2 equations, I will send this slide uh, via a link. Okay, you will get the link, updated link. Okay, equations 1, if equations 2 in equations 1, you will get the v3 value under root 2g ht minus h. This is important. And next, our main motto is calculating the time. Okay, how we'll calculate the time. Okay, okay. uh, am am is the am is the cross sectional area of the mold. Okay, cross sectional area of mold. And AG, you know that the gate area, cross section area of the gate. Okay, so if we apply the continuity equations, uh, the gate and the cross section area of the mold area, this will come out that the AM into DH, DH is the height at any time. I mean, in the previous slide, DH is the at a small instantaneous time. Suppose this is the very small instantaneous time DH at a time t. Okay, just I am calculating for small portions, DH portions. Okay, cross section area multiply DH. This is the total volume. This is the very simple thing. Okay, this is the very simple thing. You just DH, very small portion DH multiply cross section area. It is the total volume. This volume. Okay, I think it is okay. This is actually volume at very instantaneous time. This is equal to, I am comparing with the gate. Okay, AG, area of the gate, multiply velocity VG at the time, at the dt time. This is also the velocity multiply time. It will give the velocity multiply time multiply area. It will give the volume. Okay, you will understand. Okay, so if we put the VG, if we put the VG, I mean, in the previous slide, if you see, VG means V3. If we put the V3, V3 means the VG. V3 means VG. Okay, one thing I mistake here, the kinetic loss completely. That means that the V3 is not zero. V3 is not zero. It is actually head. V3 by 2G equals to 0. V3 by 2G. V3 head. Kinetic head. It is called kinetic head. Okay. This is called kinetic head. V3 by 2G equals to 0. Okay. V3 is VG. Okay. Velocity is not 0, but kinetic head is 0. Okay. Are you getting me? Just try to understand. It is a bit difficult. Not difficult. It is very easy if you think like this way. If you put the value of the VG or V3, it will coming out that AM equal to DH AG under root 2G HT minus H into dt. Okay, and if you integrate the whole things, if you integrate from 0 to HM mold height, total mold height, and the 0 to time TF, 0 to TF time, TF final time, if you calculate the TF will be TF total final time, how much time required to fill the total mold cavity, it will coming out that the mold area divided by gate, okay, 1 by 2G. This equations is important for your numerical solving, into 2 bracket under root HT minus HM. This is the total time required for the bottom getting. if you know that the total surface area, this is the aim is the what is the aim is the cross sectional area of the mold, ag is the gate area, okay, and g is the gravitational force accelerations, ht is the total height, and hm is the mold height, okay. Now you can solve the questions, mcq numerical questions. Are you getting me? Any confusion is there? Okay, I am coming to the some basic questions. The first question: casting process is considered as, what will be the first answer? Preliminary shape forming process, secondary shape forming process, constant volume manufacturing process, mass addition manufacturing process. What is the option?
Constant volume manufacturing process.
Why constant volume? Because in the casting process, the total mass, initial mass equals to final mass. There is no loss of the mass of the material. That's why it is the constant volume process. And pattern are made somewhat larger than the final casting to produce. This excess in the dimension is referred as the what? This excess tolerance, machining allowance, limits and shrinkage allowance.
Machining allowance.
Huh?
Machining allowance.
Machining allowance, okay. Next, shrinkage allowance. It is also shrinkage allowance, na? You have to also give the shrinkage allowance. You have to give the machining allowance is important. What 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 are the allowances you have
B
to
and
give?
D.
Machining allowance, MSCH, machining allowance, shrinkage allowance, and
Shrinkage allowance. Draft allowance.
another allowance, draft
Draft
allowance.
allowance. Draft allowance.
Three allowance you have to, at least three allowance you have to give. Here the option is the machining allowance and shrinkage allowance both. So B and D. Option 3 is the right option. Uh, Question number 3. Strength and permeability of the sand used in the sand casting process are mostly influenced by clay content, hardness, grain size, moisture content, type of the sand. Question number 3. This is the,
Moisture
Type
content.
of the sand.
yes, moisture
Moisture.
content. Because strength and permeability comes from the moisture content. If the if the moisture is high, I mean water percentage is high, the strength will be decreases and the permeability of the gas will be decreases. Okay. So our option number 3 is the right option. In order to facilitate the withdrawal of the pattern from the sand mold, pattern is polished to make it smooth. Allowances are given on the pattern and pattern surface is lubricated. Draft is provided on the pattern.
Draft is provided on this.
Yes, draft is
Okay,
provided.
the drafted is provided
Ha,
on the pattern.
ha. I have shown you the diagram that it is in taper form. After that, the extra material taper portions will be removed out to get the proper shape and size. Casting process is preferred for part having many details, a few details, simple configurations with no details, non-symmetrical shape. Casting process is preferred.
Many details. I
Many
think many
details.
details.
Yes, many details.
Yes.
If a complex geometry also can made by the casting process by adding what is that called? Core.
Course.
Do you remember the core? By using the core system, we can design or modify the internal portions, internal modifications. Okay. Question number 6. The draft allowance on the pattern, on the wooden pattern, in comparison to the metallic pattern, will be same, more, less, depend on the size of the pattern.
Depend on the size of the pattern.
Now read the questions carefully. The draft allowance on the wooden pattern in comparison to the metallic pattern. For the wooden pattern, wood, wood and metal. If this is your sand fill, if one is this is wood, this is wood, and same thing, and this is metal. In which cases the draft, this is wood
Wood.
and this is metal.
More on the wood side.
Yes, more on the wood, because why?
Because it is affected by the moisture content.
Uh, that is not the right answer, because
Surface finish.
yes, wood has a higher frictional property. Wood and sand have the higher friction compared to the metal. Metal and sand has a less friction. Okay, but wood has a higher friction. When you remove the wood, sorry, draft allowance. Draft allowance. When you draft allowance means that the you have to make it in a angle positions. Okay, for the wood you have to make higher angle, but for the same material, for the metal you can give the less angle. Okay, this is the draft na angle, how much angle you are giving. Okay, for the metal the less angle is okay. Okay, that's why wood has a surface higher frictional surface. That's why the answer is the more. Is it clear? Draft allowance means that the angle, what, how much angle you are giving. Okay, higher angle means that the higher draft allowance. Okay, I'm coming to the next questions. Metal requiring least shrinkage allowance. Which metal require the least shrinkage allowance? Brass, cast iron, and steel or aluminum. It will depend on the coefficient of the linear thermal expansion. Okay, coefficient of the linear thermal expansion. You will find out the brass thermal expansion, cast iron thermal expansion, and steel and aluminum. Which one have the
Cast iron.
As iron, sir.
which one have the less thermal expansion? It has a less shrinkage allowance. So according to the data, I can find out the cast iron here.
Cast iron.
Okay. Core are used to strengthen the mold stand, support the loose piece pattern, make desired recesses in the casting removal pattern.
Support loose pieces.
Surface support loose piece. No, loose piece is another thing. Strength of the mold sanding, it is not. Removal of the pattern, it is also not. Make desired recesses in the casting. Actually means it means that uh, desire recesses means that the desire different internal part or different surfaces. Our according to our desire dimension, different part we have to different core we have to apply. Is it clear? Suppose you are going
Okay, sir.
to design these kinds of shaft. Okay, suppose these kinds of shaft different. Suppose this is hollow shaft. This is hollow shaft. Okay, these kinds of these things, for making these things you have to give the core. For our desire different recesses in castings we have to use the core. Okay, So answer is the 3. Okay. The purpose of the sprue in the sand mold casting is to act as a reservoir of the molten metal, feed molten metal from pouring basin to gate. Obviously, which one is the correct?
Feed molten metals from pouring basin to gate, I think.
Ha. Because pouring basin, this is the pouring basin through the sprue, and it will come through the parting line, and it will, this is a gate, and this is the mold cavity. This is the mold cavity. This is the parting line. This is the sprue, and this is the basin. I mean pouring basin. So our right option is the 2. Metal among the following ones require more shrinkage allowance. More shrinkage allowance. So more shrinkage allowance means that the more thermal expansion coefficient. More thermal expansion coefficient. So more thermal expansion coefficients you have to. Aluminium has the 25.
Lead. According to the tabulation form, given option lead is correct answer.
Lead is correct option. Lead is the correct option. Yeah, you just check it. You just check it. The value, all the value, and which one is the lead is the correct option. Okay. Uh, what is the time? Okay. Just time. What is the middle part of the flask is called?
Thick.
Hmm. So our option B is the right option. You just remember the name chick. Bottom part of the flask. Bottom
Drag.
drag. Upper
Right.
part scope. Middle part
Oh,
chick.
cheeks.
Uh, in which type of molding cow dung is sometimes used? Cow dung is used also. Cow dung means you understand that the wood floor, wood chips. I mean, like this, not exactly wood chips. It is straw, cow dung. Okay, or coal in which option? Green sun
Green sand molding.
molding. Green sun molding. The main advantages of the cell molding is metallic pattern is used. The mold are stronger. Section can be easily obtained. High complex sections can be easily obtained. High production rate is possible. Which one is the correct option?
C.
This question is important. Sometimes these questions came, I mean, JE, junior engineer.
Sir, option C.
Option C, thin section. When the section is needed to prepared, then you have to use the cell molding. Our investment molding is done for the higher precision or
High rate of production.
no. For the for investment casting is used. This is important question. Investment casting is used where the high precision for the gold casting. Huh? Okay, these kinds of things the investment casting is used. Okay. Uh, Question number 15. Following molding machines is used to get uniform sand hardness. Which one? This you remember the diaphragm molding. Okay. Get the uniform sand hardness. Okay, diaphragm molding. Okay, just I'm coming to one numerical. Okay, this is your numerical, very interesting numerical. Determine the time required to fill the entire mold cavity along with the riser. Okay. Uh, what is this? This is the pouring basin. Pouring basin. What is this? What is this dotted line here?
Parting line.
Parting line. And your suppose here this section I am making it this section. This section is A section. When this A section is when the A section is prepared, what is the type of the gating systems we will use using here?
Bottom.
Bottom gating. Sorry, top gating. It is called top gating. Means that the material is flowing from the top side. A is the top gating. Top gate. Is it clear? सर थोड़ा देर बाद कॉल कर रहा हूँ. Hello. It is top gate. This sections is uh, this sections is B sections. I am considering that this is the B sections. For the B sections, which gate is used? Hello. B sections, which gate is used? Are you there?
Yes, sir.
Which sections is there for the B?
For the B, top, bottom.
Bottom gate. Because it is very simple. How the material will enter into the mold cavity? B section, this is the parting line. B sections, it is the material is flowing below the mold cavity. That's why B section, bottom gate. Bottom gate. This A and B total is the material, our desired material shape. Okay. And C is the and upper portion C, this section C, cylindrical section C is the, could you say what is the C? What is the portion C here in the questions? Along with the riser, C is the riser. C is the riser. So
Yes.
you have to solve total A B C total to fill the all A B C area. The total time you have to calculate. Total time you have to calculate. So the time to fill the A section A, we know the formula here. What is the formula of section A? The formula is simple. That is the time T. Okay, for the portion A. Okay, it is a top gate. Top gate. Total volume. Total volume of the mold divided by gate area, surface area of the gate, multiply under root 2G HT. This formula already you derived, na? You know this formula. You derived, na?
Yes, sir.
Total mold volume. What is the total mold volume? Volume for the A section. For this section, what is the area? What is the volume? area, cross section area 30 into 30 and height is 10. Total volume is what? Is it okay? 30 into 30 into 10, the total volume of the mold. Mold means this A area A. Is it okay?
Yes, sir.
Okay. So then AG, what is the value of the AG? Gate area AG is given here. AG is 5 centimeter square. So
Just
this is
wait.
the 5 multiply under root 2 multiply, it is in centimeter CGS unit. So 980 or 981 multiply total height. What is the total height? HT total height.
30.
No, total height is 20 na. HT this is the total height. Total height is always consider, you just remember, from the gate to upper portion, from the gate, this is the gate, from the gate to upper portion, from the gate height to upper portion is the HT. Okay, this is the 20. If you calculate your total time to require, it will come 9.09 second to fill the A
Person is.
portion A. Okay. Next, to fill the portion B. To fill the portion B, the total time to fill the portion B, it is used for the bottom getting, na? BOTTOM. Bottom getting. What is the formula of the bottom getting? This is the simple formula you should remember. Already I have derived 2 multiply mold area divided by AM by AG. Already I derived under root 2G. I think you have forgot all the things. Under root HT minus under root HT minus HM. Okay. If you put all the value, what is the AM here? AM is the 30 cross 30. AM here 30 cross 30. AM is the 30 cross 30. I am writing in the different color actually. 30 cross 30 here. And what is the AG? AG is the 5 and G value 981 and AM 30 cross 30. This is the 30 cross 30 and HT is the total. HT is the 20. HT is the here 20 and HM is the mold height. What is the mold height? From the parting line, from the gate to mold height. This is the total gate to mold height. For the B, this is 15. So this is 15. If you calculate this, the time will come 18.17 second. Similarly, you have to calculate in the home what is the required time to fill the riser portion, this section, and you have to answer the questions in the next class. Okay, and then you have to add the total time Total time equals to time required to fill the portion A plus time required to portion B plus time required to portion C. Already you have calculated 9.09 second plus 18.17 second plus you have to calculate these sections and you have to answer. Okay, I am giving you the answer. The answer is actually this answer TC is the 1.58 second. Total time will require 28.84 second. Okay. This is all about the today's classes of the first week. Okay. Next week we will solve some numerical questions as well as some MCQ questions. If you have any doubts, you can ask me. I will try my best, and I will send all the slides, whatever I have written the slide, and I have solved the numerical questions. Okay. You will you will be given through the Google Drive link. Okay. Uh, am I clear? Hello, Ajinka.
Yes, sir. Yes, sir.
Yeah. Is it clear whatever I am trying to solve or I am trying to say? Akshay, Ashish, and Gokul,
Yes, sir. Yes.
and Kaushik Pal, and
Yes, sir. It's perfectly okay.
yeah, Nanda. Next one is the
Yes, sir.
Naresh. Yes,
Yes, sir.
Bijay. Yes, Bijay. Bijay Singh. Yeah.
Yes, yes, sir.
Just you try to attend the classes on time actually. Otherwise, it is bit difficult. Okay. I'll share all the things. Okay. I think all of you from the mechanical department or something. Just I need a few introductions with you. Ajinka, you just
Yes, I'm
introduce
mechanical.
yourself.
Hello, sir.
Yes, yes. Kaushik Pal.
Hello.
Yes. Say one by
Sir,
one. One by one. Ajinka, you.
Mechanical.
Acha. Then Akshay.
Mechanical.
Yes. Then Ashish. Ashish is also mechanical. Acha. Gokul. Kaushik, you.
sir, mechanical.
Yes, I think all of you from the mechanical department. Yeah. My
सर
introduction
ये
is.
वीडियो जो है वो कहाँ कहाँ पे मिलेगा इस वीडियो का लिंक
हाँ, इस वीडियो का लिंक तुमको शेयर मैं कर देंगे। मैं आज यूट्यूब में अपलोड कर देंगे, उसके बाद तुमको मिल जाएगा, आप लोगों को सब मिल जाएगा, ठीक है।
कहाँ पे मिलेगा इस वीडियो का लिंक
वो एक ड्राइव लिंक तुम लोग को दिया हुआ है, ठीक है, उसमें मिल जाएगा। when I upload the
हम
YouTube link on that drive link, you will get automatically updated. Okay.
ड्राइव लिंक तो हम लोगों को नहीं मिला
ना ना, कुछ तो लिंक मिला है, ठीक है। अगर अगर नहीं मिलेगा, ठीक है, यू यू आई विल गिव यू, आई एम
सर
राइटिंग माई।
हम लोगों का जो हेलो सर
हाँ हाँ, यस यस।
हम लोगों का जो जीमेल है उस जीमेल में आप मेल कर देंगे तो थोड़ा सा आसान हो जाएगा
ओके। Previous time I have taken the classes, they formed on WhatsApp group. I have updated in the WhatsApp group also. Okay. You just make one WhatsApp group, then add me in the WhatsApp group. I will share the YouTube link. I think you will get the Google Drive. You will get all the things. Don't worry. Okay, next week we will meet here. Okay. Uh, okay. My introductions is I have done my BTech in mechanical engineering. Okay. Then I have done my MTech in mechanical engineering, basically tribology, industrial tribology. Then I am doing my PhD here in IIT Roorkee in the Department of Polymer and Process Engineering. Now I am working in the electrolyzer for hydrogen production. Okay, this is my background, basically mechanical engineering background. Okay, if you ask any questions or any career guidance, you can. I will ready to help you. Okay, thank you for today's session. Okay,
हेलो सर.
Thank
हाँ,
you, sir.
okay, हाँ,
हेलो
हाँ, बोलो बोलो.
सर, मैं बोल रहा था आप लोग जो आप हम लोगों को जो क्वेश्चन कराया ना आज,
हाँ हाँ हाँ.
उसमें से 17 नंबर क्वेश्चन थोड़ा सा दिखाए ना, उसका मैं स्क्रीनशॉट लेना चाहता हूँ.
अच्छा, वो मैं पूरा भेज दूंगा, आपको पूरा मिल जाएगा, PDF मिल जाएगा.
तो,
ठीक है, कोई दिक्कत नहीं है.
तो
आंसर
जीमेल में भेज देंगे आप.
हाँ, मैं भेज देंगे, कोई दिक्कत नहीं, आ जाएगा. ठीक है.
अच्छा ठीक है सर,
ठीक
आप
है.
जीमेल में भेज देना.
हाँ, जीमेल में भेज देंगे. और क्वेश्चन आंसर सब कुछ मिल जाएगा. मैं जो लिखा हूँ वो भी मिल जाएगा, सब कुछ मिल जाएगा.
Thank you,
ठीक है
sir.
सर,
Thank
थैंक
you.
यू
ठीक
सर.
है, ठीक है, ठीक है. ओके ओके.
Thank you, sir.
ओके. वेलकम वेलकम.